Hello and welcome to another video. Now for this video, we will be executing experiment number 5. It is entitled Torque, Power, and Efficiency of a Separately Excited DC Motor. Now to start, let's first open LabVault and set up our workspace. Now that we've set this up, we so for this experiment, we will be doing the connections of a separately excited DC motor. So to do that, we will let's change this to yellow and connect perform the connections for the said DC connection. Alright, now these are the connections from the motor or generator to the power supply and the data acquisition interface. Now we will be performing the connections for the data acquisition interface to the prime mover. Head on to metering so that we can see the outputs for the voltage and the current. So let's turn on the power switch and we will be adjusting the field rheostat by uh, and ensuring that it does not exceed the I2 here, over here, the I2 rating of 0.4 amps. So let's adjust it to about 24% so that we can see. Alright, so now that we have 0.356 as our ampere, that's good enough as it hadn't exceeded the 0.4 amp rating. Next, we will adjust the voltage control knob, also not exceeding the rating of 120 volts. So let's say it's about 10, 10%. There. Now we have this for our first part. So the voltage knob is 10%, rheostat is 24%, and our voltage output is 13.82, while I1 is 0.371 and I2 is 0.356 with an RPM of 137. Now to check the torque, you just have to flip this switch since this is pointing to the RPM and above is the torque. So our torque for this is 0. Now that we've done that, we can observe that the shaft of the motor and the dynamometer is rotating in a clockwise direction. It is consistently rotating clockwise as well as the dynamometer. Alright. Now let's execute the next procedure. So on the dynamometer, set the mode switch to dynamometer, which is this one, and it says to adjust the dynamometer control knob by not exceeding the nameplate rating of the motor. So let's adjust this to about, let's say, 26%. Let's adjust it to 26%. Alright, now that we've adjusted it to 26%, we can see that the armature current had increased. So There. The question is, does the field current I2 change? As you can see here, it is still 0.356 amps, so we can say that it hadn't changed. Now, our next question is, what is the HP rating of the motor according on the data recorded? So, to figure that out, let's perform a series of calculations. So, this is the HP HP power, HP rating of the motor according to the data that was recorded. So it's 0.0045 HP. Now, does the current on the armature increase? For that question, the current on the armature did in fact increase because the motor is loaded. So, in a DC motor, the armature current is directly related to the torque produced. So, the motor slowed down as the dynamometer applied load to the motor and more torque was required. So, the motor drew more armature current from the supply. That is why the current increased significantly in the dynamometer mode. Now, that is all for this experiment. I hope you enjoyed.